Good morning. Today we're going to begin the last module of the course. It begins with a look at logarithmic versus exponential form. On the formula sheet, we'll be concentrating at the very top of the page, which compares these two forms. If x is the logarithm of y with base b, then y is equal to b to the x. So we're going to use the switch in forms in order to solve for the argument, solve for the exponent, and solve for the base. So let's begin. First, solving for the argument. The argument of the logarithm is in the position of y here in the formula. So in this case, the argument is n. We begin by switching from this form to this form. And that will look like this. We write n is 8 cubed. The base is 8. The exponent is 3. 8 cubed is 512. So 512 is n. Here's a second one. Y is the argument, so we do the switch in forms to write y is equal to 7 to the power of negative 2. So again, the base is 7. The exponent is negative 2. This is the same as 1 over 7 squared if we make that exponent positive. And that means it's also 1 over 49. Okay, so we start the question by changing the form. So whenever we change the form, I will indicate that by making this kind of notation on the page. So again, here to start, we also change the form. Okay, part 2. Let's look at it, some examples where we are solving for the exponent now. Okay, here is our first example. This says that x is the logarithm of 125 with base 5. So we'll begin by switching the form of the logarithm. So we will have the base is 5 and the exponent is x. The base is 5, the exponent is x. We set that equal to the argument. Now, in order to determine the value of x, we would like to write the number 125 also as a power of 5. So with your calculator, you can determine that 125 is equal to 5 cubed. Now that each side has the same base, and it is an equation, we can conclude, therefore, that x is equal to 3. Okay, and again, we started this question with the switch in forms. Okay, now this one. Again, write down the base. The base is 16. The exponent is x. Set the right side equal to 1 over 4. Now, as we did in the previous question, we would like to write each side as a power with the same base. On the right side, recognize that 1 over 4 to the 1 is the same as 4 to the negative 1. I will be in business if I know how to write 16 as a power of 4. Well, 16 happens to be 4 squared. So we replace 16 with 4 squared, recognizing that the exponent of x is still outside of the bracket. This is now telling us that 4 to the 2x is equal to 4 to the negative 1. The exponents in this case multiply. And now I have the situation I did here. where both sides have the same base, which means we can equate their exponents. We can say that 2x therefore equals -1. And that means x is -1/2. Okay, and again, we started the equation with the switch in forms. Okay, we'll do a few more like this as well. Okay, so here is question 3. Start by writing down the base. Here's the base, it's 5. Next, give it the correct exponent. This is the exponent, r plus 1. Set that equal to the argument. This power, in this case, is the argument. Now, both sides already have the same base. We've done the big switch. They already have the same base, so we can simply, at this point, equate the exponents. So r plus 1 is 2.3, and that means r is 2.3 minus 1, or 1.3. Here's another one. Question 4. Start with the base. The base is 3. What is the exponent? It is x. We set that equal to the argument, 1/81. Here we have a base of 3. Can we write this number with base 3? You may recognize that 81 is 3 to the power of 4. After that step, it's not good enough to have the power in the denominator. So we need to next write this 3 to the x is equal to 3 to the -4. So 1/3 to the 4 is the same as 3 to the -4. And now we have both sides powers of the same base, so we can equate the exponents. So x is equal to -4. Okay, last one of this type. The base is 4. The exponent is x. We set that equal to 1/32. Base, exponent, argument. Now, here we have a base 4, but 32 is not a power of base 4. In particular, 4 squared is 16, but 4 cubed is 64. So 32 is not a power of 4. So what can we do? We can switch both of them. They are both powers of 2. So we can replace 4 with 2 squared. And we can replace 32 with 2 to the power of 5, like this. Again, not good enough to have that power in the denominator. So we would then write here 2 to the 2x equals here 2 to the -5. And now we can compare these and suggest that the exponents are equal. So 2x is -5, x is -5/2, or -2.5 if you prefer. Okay, one last thing we need to do, and that is make sure we know how to solve for the base. Okay, so here we will look at 3 examples. Example 1. And as you might imagine, we begin by switching forms. So we write the base is b, the exponent is 4, and we're going to set that equal to 625. Now, b to the 4 is 625. This does mean that b is the 4th root of 625. In general, what we're trying to do is get b to the 1 on this side. So that means taking b to the 4 and raising it to the power of 1 over 4. Because now 4 times 1/4 will give us b. So if we raise the left side to that exponent, we must also raise the right side to that exponent. Again, on the left now, we will have b to the 1. And on the right side, we just have to figure out how to put this into our calculator, 625 to the 1/4. So I'm going to show you, okay? So 625, then your exponent button, which you know is here. And then we're going to put 1/4 as our exponent using our fraction button, but we also have to bracket it. So that's very important. So 1 over 4, like that. Okay? Push equals, and you will get 5. Okay, so the base is 5. Here's the second one. So we begin like that with the change in form. The base is b. The exponent is 2/3. We set that equal to 4. Now, in order to get b to the 1 here, we have to take b to the 2/3 and raise it to an exponent of 3 over 2. You see, it's the reciprocal of this fraction. Because now when I multiply these fractions together, I get 6 over 6 or 1. Okay, so since I raised the left side to an exponent of 3/2, we have to also raise the right side to an exponent of 3/2. The left is now b. And again, on the right side, I simply need to work out 4 to the 3/2. Okay, so here we go. 4 to the, in brackets, 3 over 2, close the bracket, equals, and we get 8. 8. Okay, and as I was saying a moment ago, 625 to the 1/4 is also the 4th root of 625, okay? And 4 to the 3/2 means the same thing as the square root of 4 cubed. So it's the same as 2 cubed, or 8. So you can evaluate them this way if you prefer. So this is also 8, and this is also 5. Okay, one last example for our lesson today. The base is b. The exponent is -1/2. We will set that equal to 1 over 4. If we want b to the 1 on the left side, we will need to use -2 here as our multiplier, because -1/2 times -2 will give us 1. Also, -2 is the reciprocal of -1/2. So now we need to work out this number, 1/4 with an exponent of -2. The left side is b to the 1, or b. Okay, 1/4 to the -2. So 1/4, okay, with an exponent of and then -2. So we could put a bracket around -2, but I don't think it's required. We need to bracket our fractional exponents for sure. And that's going to give us 16. Okay, so I hope that you were able to follow that lesson quite well. So what you want to do is go into Blackboard, make sure you notice that I have posted a copy of this formula sheet. And after viewing this lesson now, I'd like you to try the problems that I posted in Blackboard. So I've posted a couple of worksheets for you, and the questions there ask you to do what we have just done together. Solve for the argument, or solve for the exponent, or solve for the base. Okay, solutions will be posted for those exercises also. All right, have a good day.